Okay, we are back with part 2 here. We're going to be factoring by grouping. You guys have never seen this before, but it shouldn't be hard. Actually, it will only happen when you have a 4-term polynomial. As you can see in these 4 problems, they all have 4 terms. And what it is, as long as you guys are good on GCF, you're going to be great on this. So let's factor this by grouping. First of all, they are going to be given to you in standard form. If they're ever out of order, make sure they're in standard form. So when I tell you to factor by grouping, you are going to put 2 parentheses here. You're going to notice that this is actually going to look pretty similar to when we're factoring hard trinomials and using the A times C method. So we GCF twice. The GCF of the first group is x squared. So x to the third divided by x squared is x, and then minus 3. The GCF of the second term, be careful. Remember, when the first term is a negative, your GCF must have a negative. And your GCF there would be negative 16. 16 goes into 48 3 times. So carefully divide by negatives here. Negative 16x over negative 16 is positive x. And 48 divided by negative 16 is negative 3. Notice something. Notice these are the same. That means you're doing it correctly. So now we can go further and rearrange into 2 binomials. The one has the GCFs put together, the x squared minus 16, and the other has your matching x minus 3s. Now, as always, you do have to check to see if you can factor further. This guy here is actually a difference of squares. You can keep going there. X plus 4, x minus 3, and then bring down the x plus 4, x minus 4, and then bring down the x minus 3. And now it's completely factored. Okay, letter B, factor by grouping again. So put in your 2 groups. Your GCF of the first group is x squared. Divide by x cubed divided by x squared is x. Stylus is garbage. Plus 7x squared over x squared would be 7. The GCF of your second group, notice again, it starts off, your first term is a negative, so your GCF must be negative, and it's going to be 9, goes into 63. And then we divide by negative 9 to have x. Negative 63 over negative 9 is positive 7. Now, they match here, so we can rearrange them. Oh, damn. Stylus is not making good contact with the screen. X plus 7 here. That matches, and your GCFs get put together, your x squared and your minus 9. Now, bringing this down, this guy right here is a difference of squares, so that would be x plus 3, x minus 3. And that's done being factored. Letter C, factor by grouping again. Put your 2 groups. GCF of your first group is 9x to the second. Divide carefully. 18x cubed over 9x squared is 2x. Plus 9x squared over 9x squared is just literally the number 1. The second group starts with a negative, so that means we got to pull out a negative, and it would be negative 4. So carefully divide by negative 4, and that'll give you 2x plus 1. Notice they match. 2x plus 1's match. We are good to rewrite. I should say 9x to the second and minus 4. So, can I factor more? Yes, I can. Not the 2x plus 1, but this guy here is a difference of squares. So that would be 3x plus 2 and 3x minus 2. And bring down your 2x plus 1. Letter D, factor by grouping. GCF of the first group is 2x to the second. So divide to have 1x plus 2. GCF of the second is 3, so put a plus 3. And divide by 3 to have 1x plus 2. And now they match. Right here, they match. So let's rearrange. There's your x plus 2s and your GCFs. Put them together. Can you factor further? That 2x squared plus 3 actually cannot be factored any further. So this guy is done. All right, now we're going to learn, we're going to take what we just learned, our factor by grouping, and we are going to learn how to solve. We have equations now. So we're actually going to find out what the x's are. So GCF of the first group is x to the second. So it'll be x plus 3 after dividing. Your second group starts with a negative, so that should be a minus. GCF is minus 4. That'll be 1x plus 3. Okay, let's rearrange into our two binomials. Can we factor more? Yes, we can. This is a difference of squares. So it'll be split up, divided into x plus 2, x minus 2. All right, answer time. We're going to get 3 answers here. We could do the shortcuts here. The first one will be negative 3, negative 2, and 2. Letter B, factor by grouping, 2 groups. GCF of the first group is x to the second. So that'll be x minus 4 after dividing. GCF of the second group is just 2, so plus 2. That'll be 1x minus 4. They match, so let's rearrange them. We got x minus 4, and we have x squared plus 2. So the x squared plus 2, I cannot factor that any further. So we're going to go ahead and answer here. So the first one, you could just take that quick shortcut. X is 4, no problem there. This guy, the second one, you want to solve by square roots, so we're going to get x squared by itself. We're going to subtract 2. Then we're going to take the square root of both sides to cancel the exponent. And we don't forget your plus minus. And an I comes out for the square root inside. Guys, please make sure when you're pulling out an I, don't put an I after the square root. Put it to the left before the square root, such as I'm showing here. Because if you put it at the end, sometimes some of you were accidentally putting the I or leaving the I in the square root. So please make sure the I comes out. And then, of course, that's done because you cannot simplify the square root of 2. All right, another one. Factor by grouping. GCF of the first group is x to the squared. Divide by x squared to have 2x plus 1. GCF of the second group, got to be careful, starts with a negative. So negative 5. So that will divide to have 2x plus 1. Let's rearrange them. X squared minus 5. I know it looks like a difference of squares, but 5 is not square rootable, so that cannot be factored further. Neither can the 2x plus 1. So we need to solve them. We don't want to try shortcuts here. Alright, so the first one, set it equal to 0. We're going to solve by square root since it has an x squared. We're going to add 5, then square root both sides to have x equals plus minus and square root of 5. And the second one, we're just going to get x by itself since it has no exponent. So we're going to subtract 1 and then divide by 2. And there's another answer. So we got 3 answers here. And almost done. Last one. Factor by grouping. Put my groups. GCF of the first group is x squared. Divide by x squared to have x minus 7. GCF of the second one is 9. 9 goes into 63, so plus 9. Then divide by 9 to have x minus 7. And let's rearrange. So x minus 7, since it doesn't have an exponent to it, you could just take the shortcut. X is 7, because 7 minus 7 is 0. However, the x squared plus 9, again, you can't shortcut that. It has an exponent. So you're going to have to solve that by square roots. You're going to get x squared by itself, so subtract 9. Square root both sides to get rid of the exponent. Don't forget your plus minus. And the square root of 9 would be 3, so the square root of negative 9 would be 3i. So you have a real solution here, 7, and 2 imaginary solutions, 3i and negative 3i. Okay, so you just learned the newest way of factoring by grouping. Again, you can only do that when you have a 4-term polynomial. And that's it. That's all.